Apartment buildings have become increasingly common in Vietnam due to rapid population growth and fast urbanisation, which challenges both urban planning and quality of the living environment. Apart from high-end apartment homes and new urban areas which represent new forms of urban architecture, a special focus should be put on low-income housing as well, as it considers building cost, living expenses, the environment and livelihood for occupants. Currently, many apartment homes are costly, yet they are very poorly designed, deteriorate quickly and have an unhealthy living environment. These facts require more practical solutions to enable the large majority of Vietnamese city dwellers who are low-income wage earners to afford an apartment, reducing the burden of their hard life.
Không đạo diễn anh cân người nhé.
Chỉ ví dụ thế thôi.
Tan Hoa Lo Gom apartment building, located at Ward 11, District 6, Ho Chi Minh City, is one part of an international development project to resettle the poor wage earners living on the banks of the polluted Tan Hoa Lo Gom Canal. The project was to assist the locals to afford a house themselves. The building complex consists of 3 apartment blocks, a flea market and a common room with 72 apartments in total. 2 of the resident blocks are 3 stories tall and one of them is 4 stories. Wide corridors run parallel along both sides of each block. Lush greenery surround and dots the buildings from different angles.
So the history of the project is that the World Bank and the French Development Agency have a program to renovate all the Tan Hoa Lo Gom canal, and they asked to the People's Committee of Ho Chi Minh City and to the Belgium Technical Corporation to work on this specific project to resettle 250 poor families living along this canal in a slum area. So before to start the construction, we made a large socio-economic survey to really well understood who are the people we work with. So what is their job, how much they earn every month, how they live, etc. And after we can adapt the architecture and the project to make sure it corresponds to their needs. That's why we build some apartments blocks, but as well a marketplace, some workshop for people working with metal or with wood, and many common place to make sure people can walk around their apartments.
Due to the land location, all building blocks are at a 45-degree angle in the east-west direction. B1 is the largest block of the building complex. Looking at the sunpath diagram, it can be seen that B1 block is only affected by morning sun, as it is shaded by greenery grown in the centre courtyard, and the A1 and A2 blocks in the afternoon. In order to make most of such an advantage, each block has up to 72 apartment suites. During the rainy months of May, June and July, A1 and A2 are often exposed to sunlight from morning to evening. During dry months, from November to January, the 2 blocks are mainly impacted by afternoon light exposure. As such, the architects tailored the design to block sun rays from the buildings, for instance, growing trees in the front, central and backyards. Moreover, the blocks can shade each other by facing the one same yard. Distance and height of the three buildings are designed to ensure that every block is well ventilated. Corridors and staircases are used as a simple yet effective ventilation system. There is also a seasonal change in wind direction at the building location. During the rainy months, from June to October, the prevailing wind direction is westward and southward, blowing from the Indian Ocean. During the dry months of November, December and January, the prevailing wind direction is northward and northeast. From February to May, the main wind direction is southeastward. The corridors of B1 and A2 blocks are wide enough for the wind to pass through the apartments. Proper distance and heights of the building blocks also facilitate airflow and natural ventilation. Within a building block, ventilation is simple yet very effective. A1 serves as an example. The construction uses double-layer roofing technique for attic ventilation. The double-layer roof consists of a suspended ceiling, roof beams, an aluminium layer and a fly screen. The roof is painted light green to reflect solar heat and emit absorbed radiation. The dry season in Ho Chi Minh City is harsh with intense solar radiation. As the city location is well within the region north of the Tropic of Capricorn, the sun rays are perpendicular with the Earth's surface, and thus solar heating is intense. Solar heat gain through the roof is anywhere from 5 to 9 times higher than through walls. Heat fluctuation is also considerable. Attic insulation with free flow of air in the roof has become the best configuration for the warm climate of Ho Chi Minh City. As this kind of vented roof allows airflow to circulate continuously, indoor heat gain will be reduced significantly. The heat absorbed into the building splits into 2 layers. While the upper layer is pushed out through the circulated airflow, the lower layer transfers heat through conduction into the building. The distance between the suspended ceiling and the aluminium layer is 30 centimetres, which is a reasonable thickness for the air circulation. Hence, a vented roof is a good construction solution for hot, humid zones. Studies have shown that a greater thickness means greater heat insulation. To optimise air ventilation, the attic insulation should not be thinner than 10 centimetres. The thicker, the better. Yet vented roofs should be limited only from 25 to 40 centimetres in height. According to scientific research, for any form of attic insulation to function at its best, wind should blow at an angle of 0 to 30 degrees. When wind blows at the angle of 30 to 60 degrees, attic insulation will lose 10 to 20% of its efficiency. Thermal insulation lowers its efficiency up to 25% if wind blows at an angle of 60 to 90 degrees. As such, the building blocks were designed to allow wind to blow into one of the buildings at the angle of 0 to 30 degrees in all seasons. Also, the use of aluminium awnings provides additional shade for the construction. In June, the additional awnings provide shade for the A2 block from 11 a.m. to 2 p.m. The wide corridors create considerably large buffer zones, providing both effective heat insulation and shading. Large windows on both sides are used to vent apartments by circulating airflow from front to back. The only shortcoming is that rain comes through these windows. Architects applied crawl space ventilation in the design of the construction. Two types of air bricks are used to create venting holes on walls, one that allows light through and the other that allows wind through. This helps the apartment optimise natural light and ventilation. Natural light analysis shows that 95% of the apartment blocks have enough natural light for daytime activities without using any artificial light sources.
So the first idea was to propose different type of apartments, because Vietnamese family, sometimes you have 2 people, sometimes you have 5 or 10 people in the families. So we would like to have different size of apartments to make sure all the families can find apartments adapted to their needs. To make sure the cost is low, we propose to have to give to the people only the wall, the floor, a small bathroom and a kitchen. And afterwards we say to the people, you can do what you want to add mezzanine, to add 1 floor in your apartments, and to put some partitions in it. So you adapt your apartments according to what you need.
Gia đình tôi được tái định cư, bố trí lên đây ở, tại vì đông người á, đông nhân khẩu. Rồi về đây ở đó là có sửa chữa lại chút đỉnh, về có làm thêm gác với phòng, tại vì mấy đứa con nó ở, mấy đứa con nhỏ nó ở, với mấy đứa cháu nữa.
Thì sửa chứ phải ý muốn của con cái nó tính sao nó sửa thì mình ngăn ra mình làm cho nó hợp lý cho trường cái cầu thang, đừng cho nó rộng rãi đường đi đó. Có hai chồng cái con cái nó nghỉ ngơi, cái này cũng ở vậy.
Khi mình ngăn thế này mình ngăn bằng chất liệu gì và cái kinh phí nó hết nhiều không ạ?
Thì chỉ định thì đúng ra là mình đo dùng bề ngang nhiêu, rồi cái chiều dài nhiêu đó mình ngăn phòng như là nội nhôm, rồi thạch cao, thì cũng kêu thợ để làm mình đánh giá nó thu nó làm chung hết bao nhiêu gì đó, rồi mình đưa số tiền để làm vậy đó thôi.
Giá không mắc lắm đâu đúng không ạ? Các thành viên sống ở trong những cái căn phòng nhỏ đấy thì phản ánh thế nào ạ?
Thì chung ra đây thì nó không nổi mà nó ban ngày đó gió vô mát mẻ, rồi có nhiều khi nó hơi được một mái.
More than half of the Tan Hoa Lo Gom's residents are able to enjoy the common green space of shrubs and bushes in the building's central yard. Its open landscape also consists of ornamental grasses and gardens. The blocks feature shaded walkways and pathways. Spacious common areas are scattered across the apartment buildings. Wide corridors also serve as a common space for children and adults alike, as well as the green space, park lounge chairs and walkways. The building cost of the Tan Hoa Lo Gom apartment building was €125 to €170 per square metre. Overall cost of the building was $597,285 US, or $112 US per square metre. As such, the average cost of each apartment ranged from $88 to $234 US per square metre. In greater detail, each apartment was sold at $2,833 US to $12,518 US. These apartment blocks were built to relocate low-income shack owners living along the polluted Lo Gom Canal. Therefore, each relocated household was eligible for a 10-year low-interest loan with a monthly interest of $25 US, which is equal to 15% of their monthly income. The average cost of each apartment is 3/4 lower than the market price. Based on the latest survey conducted by Asia's Green Building Database and Network, E4G, 90% of Tan Hua Lo Gom's residents are happy with their apartment's comfortable environment, such as air room temperature, natural ventilation, natural lighting, green space, humidity, odour and air quality. More than 70% of the surveys show high satisfaction with the above-mentioned building comforts, rating them from good to excellent. 90% of the surveys were particularly happy with natural ventilation and lighting. After being used for 10 years, the applied architectural solutions have shown their benefits, enabling the home occupants to save a considerable amount in energy expenses. According to the survey, all residents of the apartment blocks have lived here since 2005. No relocation has ever been recorded. More noteworthy, these apartment blocks also meet specific standards set by Circular No. 14, 2008 by the Ministry of Construction, especially regarding requirements of ventilation, natural lighting and space. Tan Hua Lo Gom is a smart solution to the mental math of building cost. Inexpensive green solutions are the key to solving this challenging question. Many of the solutions had no upfront investment, such as the natural wind trap, optimised insulation, optimised shading, which were either being ignored or overlooked. Low-cost housing is not only feasible for apartment blocks, but also for tube houses. The Nest provides that building a green and affordable home from recycled materials isn't something up in the air. Covering a total area of 100 square metres, the two-storey home occupies an area of 40 square metres and cost $16,460 US. The house is for 4 people and located at Binh Duong City, a fast-growing adjacent urban area to Ho Chi Minh City. The rectangular tract of land faces north and northeast with its back towards the southwest. The site boundaries run along the southeast and northwest direction. Analysis of solar path shows the house front is exposed more to the morning sun during the mid-year months. During the year-end months, the sun tilts mostly towards the south, and thus the house backyard is more exposed to solar heat. The prevailing wind direction of the Nest is similar to the Hua Lo Gom apartment blocks. During November, December and January, the primary wind direction is northward, southward or southwest wind is more prevalent during the rest of the year. As both the house front and back are able to catch breeze, it is windy all year round. Moreover, Binh Duong Province and Ho Chi Minh City are less prone to storms with a tropical climate of two distinct seasons, dry and wet. Due to such special weather condition, the architects developed a new approach to the house design, providing both living comfort and health for the house occupants. Instead of the traditional approach of setting human living condition within the four wall boundaries and a window, this house was designed in a way that enables its owners to enjoy nature. The house is covered by wire mesh, allowing the house owners to grow lush climbing plants for green, shade, noise, dust and better security. This strategy changes the traditional mindset of house owners who often believe that only things bounded within four walls are actually theirs. This space seems to be open, is in fact closed. The space is also very green with lots of plants. A house is also built within this green coverage. However, it is very different from traditional brick houses, as it is very well ventilated, well lit, and close to the surrounding nature. Also, the house's upper part is quite light, saving considerably the cost to build its foundation. Wind ventilation, which is also known as cross ventilation, is applied as it's the best venting method in Vietnam's tropical climate with hot and humid weather. The land shape, the prevailing wind direction, and an open design enable the house to catch plenty of breezes all year round. The corridor have gaps between the timber slats, allowing better ventilation between the floors. Such design minimises the use of air conditioning, enabling the house owner to save money on their electricity bills. The house walls and roof are made of aluminium, which are heat-absorbing materials. However, thermal insulation and thick climbing plants work greatly in protecting the house from intense solar heat. Moreover, as rooms are well designed, the house is still very well ventilated. The open spaces allow natural light access so that the house occupants do not need to turn on lights during the daytime. Also, the house utilises the new saving energy T5 light bulbs. The majority of building materials are recycled materials, including windows, doors, aluminium roofs, aluminium walls, porch and shelves. However, after some architectural treatment, the used materials were arranged in a way that makes the house look very well designed and neatly decorated. The architecture firm started collecting recycled materials to execute this housing project from late 2012 and early 2013. Materials were collected from friends and from other demolition debris, mostly in Ho Chi Minh City and Binh Duong Province. As such, thanks to the architects, materials that would have otherwise been thrown away as trash are now turned into useful products. Moreover, these recycled materials beautify this home, providing the house owner a healthy and comfortable environment. Undoubtedly, creating a good living environment is based more on good design and consideration of the architect rather than an expensive solution. The overall investment of this house is $16,500, including the design fee, construction cost, interior design and landscape. This cost is affordable or even cheap compared to the benefits the owner could get out of this special living space and environment.